Welcome to chemistry. A frequency of radiation of the wavelength 5 multiplied by 10 to the power negative 5, and then we have to find out the wavelength times the frequency. Remember that V they represent the frequency, and then the constants is 2.998 multiplied by 10 to the power 8 meter all over a second multiplied by the wavelength. So that's the speed of light in vacuum. And then we have that equation. So wavelength times frequency is equals to constant. So constant over frequency is wavelength. So the wavelength is there given. Frequency is equals to constant over wavelength. So constant. So we need to put the constant value, that is 2.998 multiplied by 10 to the power 8 meter per second. And then we have the wavelength, which is 1 over 5.0 multiplied by 10 to the power negative 5 meters. So the meter cancels out, and then let's find out the value. 2.99 power 8 multiplied by divide by 5.0 multiplied by 10 to the power negative 5 gives us 5. So our frequency there is going to be 5.996 multiplied by 10 to the power 12. That's per second. So that's our answer. So answer is 5.996 multiplied by 10 to the power 12 per second. We're almost 6.0. So we have there on B our wavelength is constant over frequency. So finding the wavelength would be the constant is 2.99 multiplied by 10 to the power 8 meter, all per second, multiplied by our value, which is our frequency there, which is 2.5 multiplied by 10 to the power which means 10 to the power 8. And then the seconds cancels out, so we have let's find out. We have even that cancels out, so it's 10 to the power 8 cancels out, and then we have 2.998 that will be meter. Remember, the meter doesn't cancel out, there's no meter that side. So 2.998 meter divided by 5 giving us they are giving us 1.1992. So that's equivalent to 1.1992, equivalent to 1.2 meter. So that's our answer for B. C, they want to know if the radiation for A or B can be detected by X-ray detector. So X-ray detector has a frequency. That's the frequency that we are given for A, and that's the frequency for B. And then we know that X-ray frequency has to have the frequency has to have power 18, and then we know that neither of them has 10 to the power 18 as part of their value. So A is infrared, and then B, that's going to be radio. Okay, so the radio falls under that category. So those are the frequencies of A and B. They fall under those categories, that range. And then we also know that that's fine. I wanted to talk about gamma. So the distance that electromagnetic radio travels in 10.5 femtosecond. So femtosecond, that's 10 to the power negative 15 seconds. F for femto, so Fs femtosecond. Now we know that distance is that's second there. So distance is speed multiplied by time, and then our speed, that's speed of light, which is c multiplied by the femtosecond. So that's going to be 2.998 multiplied by 10 to the power 8, which is meter per second, and then multiplied by which is 10.5 multiplied, that's Fs, multiplied by 1 times 10 to the power negative 15 for the femto, and then we have over Fs, so that is second there. and that's Fs there, that's conversion factor. So the Fs cancels out, and second cancels out, and we're left with a meter. And so 299 multiplied by 10 to the power 8 multiplied by 10.5 multiplied by 10 to the power negative 15 gives us 0,00. Let's say 0, we have 5 zeros before the 3. There's 1, 2, 3, 4, and the 5, 3, and then 1479, and that translates to 3.15 multiplied by 10 to the negative 6 meter. That's equivalent to 3.15 micrometer. So micro is the power negative 6, and that's our answer. Thank you so much for watching, and this is your tutor Black Adam. If you have any question, please don't hesitate to leave below, and don't forget to follow or subscribe. And that's it. Just remember the equation that wavelength times frequency is equals to constant. Yeah, so thanks a lot for watching, and don't forget to follow or subscribe.